Okay. Again, independent, again, two types: voltage, current. Voltage source, again, it can be a ideal voltage source or practical voltage source. Current source also can be a ideal or practical source. Okay. So independent, I think it is clear. Now for dependent voltage sources, we saw four kinds, the four possible combinations. So for dependent sources, two things are required. Now, what kind of source it is? Same as current or voltage. So be it dependent, but it should have either it should be a voltage source or current source. So that is the first thing. But since I am talking about dependent, if it is a voltage source, it should be dependent on something. Again, if it is a current source, again it should be dependent on something. So in that case also another two cases comes. So total four cases happens. Like it is a voltage source, but it is controlled by another voltage. It is a voltage source, but it is controlled by another current. Again, it is a current source, but it is controlled by another voltage. It is a current source, it is controlled by another current. So we started with this voltage control voltage source. Okay, so you can see like in a circuit, this circuit we will means how to deal with this kind of a circuit with dependent sources that we will see in detail today. Okay, but you can see here, like again, how you will identify whether a source is dependent or independent in a circuit. The independent sources are given like in a circle or like cells in a battery, like this. Okay, it's a cell, it's a like source. Okay, independent voltage source. So independent sources are mainly denoted using this circle. Okay, inside the circle something will be given either plus minus, that will denote a voltage source. If it is a arrow pointing in upward or downward direction, then that will be a current source. When you will see this diamond shaped like structure, okay, it will definitely be a dependent source. Now, again, inside that diamond structure, you will see that plus and minus. If it is a plus and minus, then it will be a voltage source. Similarly, on the other hand, in the diamond shaped symbol, if there is a like arrow, either facing upward or downward, that kind of arrow will denote that it is a like current source. Okay. Now, so we can say that it is a voltage dependent voltage source. If there is a diamond shape and plus minus inside it, we can say that it is a dependent voltage source. Now, but what it is depending on? So for that, there will be something written just beside it. We'll see examples. So there should be something written beside it. So mu of VAB. That means this shows the dependence. Okay, so it is dependent on VAB. Now you have to search the circuit. Where is VAB? It will also be marked. Like here, the VAB is marked as the voltage in between these A and B terminals. So it is a dependent voltage source and it is dependent on the voltage between these two terminals A and B. Okay, how to deal with this in a particular circuit while analyzing, that we will see. Okay, that we'll see in some example, but this should be clear. This voltage source is a dependent voltage source and it is dependent on some other voltage. And mu comes is a constant. Constant, if you say that mu, if you take, again, VCD is proportional to VAB. Okay, VCD is proportional to VAB. Now, when you remove this proportionality sign, so VCD will be equal to mu of VAB. Now, mu should be equal to VCD divided by VAB. It is a ratio between two voltages. So it may denote gain. Okay. If it is greater than 1, mu is greater than gain, you are getting a gain. If it is less, then it is attenuating. Okay. So mu is a constant, it denotes gain, it do not have any unit. Next, again, it is a diamond shaped signal and inside it there is a plus and minus. So definitely it is a dependent voltage source. Now you have to see beside it what is written. It is written IAB. That means now you have to search the circuit where IAB is given. You can see that, okay, this is IAB. IAB is the current that is flowing from the terminal A to terminal B. Okay. That means it is a dependent voltage source. It is a dependent voltage source, but it is controlled by some current. So that's why it is current controlled voltage source, or CCVS. The first letters I am taking. Again, diamonds like shape and there is arrow. So definitely it will be a current source. But this is now you have to look beside it, beta of IAB, that is dependent on current. So it is a current controlled current source. Similarly, this current source dependent on VAB. So it is a voltage controlled current source. Okay. Is it clear? Good afternoon, Vishnu. Is it clear? Whoever were asking this.
Yes, sir.
Okay. Now we will start with what we are discussing where we left in the previous class. Just a brief like revision. The two important concepts that we learned yesterday were KCL and KVL. KCL, Kirchhoff's current law, it finds out different nodes. So what is the definition of node? Definition of node is it is a connection or interconnection of two or more elements. By element, I mean it can be active element, it can be passive element. Okay, it's the interconnection of two or more. So first see where are the nodes. Now once you identify a particular node, then you have to see how many currents are flowing in, how many currents are flowing out. Since node cannot store any kind of a charge, whatever charge, by current I mean charge, I is equal to dq by dt. Okay, so uh, how much charge is flowing in or how much current is flowing in, that should be equal to how much charge is going out or how much current is flowing out. Okay, so as a result, we have used some kind of a convention like sign convention. So we have considered if a current is going into the node, we'll consider it as negative. If a current is going out of the node, we'll consider it as a positive. Okay, again KCL based on conservation of charge. A node cannot store any kind of a charge. It cannot destroy, it cannot add any charge. So whatever is coming in, that will go out. So here we have seen that it is going in, I1 is going into the node, so minus I1, I2 is going into the node, so minus I2, I3 and I4 are going out, so plus I3, I4. If you take the minus sign on the other side, on the right hand side of the equation, you are getting I3 plus I4 is equal to I1 plus I2. Okay. In either way, you can write the equation. Either here in terms of plus and minus, or just take, okay, whatever is coming in equal to whatever is going out. Anything, both are like correct. We saw example, KVL, it's based on the conservation of energy. Now KVL applies, to apply KVL, you have to see where are the loops. Loop, what is loop? I've already discussed, is a closed path through which current can flow. So you have to identify loops. In a loop, the sum of the voltages, okay, that should be equal to 0. That means some may be supplying the energy, positive voltage, that means they are supplying energy, negative voltage, that means they are absorbing energy. And again, I have shown you that what is the relation between V, voltage and energy. Voltage multiplied by I, okay, that means power. Power multiplied by time, that is energy. Okay, both time in a particular series circuit, current remains same. So all the all the terms will be multiplied by the same current. So that you can ignore. All the terms will be multiplied by the same time. So the only thing that also you can ignore. So the only thing that is left is voltage. Okay, so positive voltage means supplier of energy, negative voltage means like absorbing energy. So whatever energy is being supplied in a particular loop, that much amount of energy can only be consumed because we are not adding any more energy from outside. That's why conservation of energy applies here. So we saw this example. Now what was the convention we used? Like if a loop is given, then you have to always move in a clockwise direction. Okay, you have to always move in a, first thing you have to move in a clockwise direction inside the loop. Okay, while moving, let us say first you are encountering this green element. Then while moving in a clockwise direction, you have to see whether first you are encountering the positive sign or negative sign. If you are encountering the negative sign first, That means you have to write minus of V1. Okay. Then when you are encountering the blue element, then you are first encountering the positive sign, so plus V2. Again, when you are encountering, you are moving in a clockwise direction, you are encountering the red element, then you are encountering the minus sign first. That means you are moving in clockwise direction. Minus sign first, so minus V3. So if you take the minus on the right hand side, it will be V2 is equal to V1 plus V3. Okay. So these are the basic two like concepts of KCL and KVL. Now we'll use this KCL and KVL in our nodal and mesh analysis. Yesterday we started with the mesh analysis. And before that, we also discussed voltage and current division. These are straightforward. If you have any doubt, kindly raise. Otherwise, I will move to this mesh analysis. This star delta conversion, I will come later while solving problems. So in mesh analysis, the first thing you have to do is identify how many number of meshes are there. So like for each mesh, okay, you have to assign an unknown current, and our main aim will be to find out that current in that particular mesh. So how many number of meshes are there? For that, you have to see that how many number of branches are there. So correctly, you have to identify how many number of branches, then how many number of nodes. You have to subtract the number of branches with the number of nodes and then plus one. So this many number of unique mesh will be there. Now, what is a mesh? Before mesh analysis, you have to know what is a mesh. So previously we learned that what is a loop. It's any closed path. But mesh is also a loop or a closed path which do not have any more loop or closed path inside it. Okay, that is the main way of identifying the mesh. So if a circuit diagram is given, then you can easily find out what is the mesh. We did this like exercise, identifying the number of meshes just by seeing. So you have to find out what are the loops, and you have to identify whether there are any other loops inside it or not. If there are no more loops, then it will be a no more loops, then it will be a mesh. Okay. So this is a mesh analysis. So this is the circuit we like started yesterday. Okay, this is circuit. So for identify, you can clearly identify what are the meshes, but for complex circuit, it may not be easy. Okay, for that, you can always verify your answer or whatever you are identifying, whether it is correct or not. That you can clarify or that you can verify by using that formula. So for this circuit, how many number of branches are there? So before identifying the number of branches, you have to identify the number of loops. Here, what are the loops? This one, because the interconnection of R1 and B1, this is again a node because the interconnection of R1, R2, and R3. It is again a node which is the interconnection of R3 and B2. It is again a node because the interconnection of B1, R2, and B2. Okay. Now there are then 1, 2, 3, 4. Four nodes are there. Now, what are the branches? What are the definition of branches that we discussed? Branch is a path between any two nodes. Okay. So if this is a particular node, if this is a particular node, so between this is a path. Again, if this is a particular node, this is a particular node, between in between these two nodes, this R2 is the path. Similarly, this one is a path or branch, this one is a branch, this one is a branch. So how many number of branches? 1, 2, 3, 4, 5. 5 branches are there. So 5 branches, 4 nodes. So 5 minus 4, that is equal to 1. 1 plus 1, it is 2. So we are using this formula. Number of branches minus number of nodes plus 1. So you have correctly identified that there are 2 meshes. Okay. So now the next step will be to assign an unknown current in clockwise direction to each and every mesh. Here, we are assigning the current. Let us say this is mesh 1. As we have seen here, this is mesh 1, this is mesh 2. So what we are doing, we are assigning a current I1 in mesh 1, we are assigning a current I2 in mesh 2. Okay, I1 and I2 we don't know, it is unknown. At the end, we will find what are these values of I1 and I2. Now, in each and every mesh, now we have to apply KVL. KVL, you know, it is the conservation of energy, and you have to move in the clockwise direction and see which sign you are encountering first, and in that way you have to write the equation. So first, let us start with mesh 1. Okay, so now we are assigning this. So first, what you have to do? Let us say this is your mesh 1. So there is like voltage source. In again, this is an independent voltage source. This is R1. This is R2. This is R3, and this is another voltage source. Okay. What you have done, you have considered some unknown current I1 in clockwise direction in mesh 1. You have considered an unknown current I2 in loop 2. Okay, in loop 2. The exact values of these voltages are given here. It is 28 volt, 4 ohm, 2 ohm, 1 ohm. On yeah. So sorry, there is a phone. Uh, uh, so yes. So we are considering a unknown current I1. Okay. Now, while applying KVL, you have understood that you know you need to like where the plus and minus sign was there. Then only you can see if you move in clockwise direction whether encountering the positive or negative sign first. So it is very easy. This is the positive part, this is the negative part. That you already know. This is the positive part, this is the negative part. But what about the resistances? Now this is resistance R1 of value 4 ohm, let us say. This is resistance R1 now. This is again or of 1 ohm. This is of 2 ohm. This is of 28 volt. This is of 7 volt. Okay. Now, here you can write, okay, if you move in clockwise direction, you are seeing the negative sign first. So you can write minus 28 volt. But what about this resistance? In resistance, the current flows, there is a voltage drop. That means it is absorbing. It is absorbing the energy. Whatever energy supplier is the this battery, and this resistance, it absorbs energy always. Okay, for inductor capacitor it is bit different. It depends on cycle, but for resistance it always absorbs energy. So if it's absorbing energy, that means it is working in opposition to the energy supplier. If the energy supplier is in a particular direction, the energy that is being absorbed by the resistances, that should be in the opposite direction. So if the energy supplied by the battery is this plus minus, then definitely if the current is flowing in this direction, okay, current flowing in this direction, so the voltage here it will be plus, here it will be minus. Because like simple Ohm's law, this is the battery, this is the resistance, this is plus, this is minus, then current will flow in this direction. Similarly, current flowing in this direction, that means this should be plus side, this should be minus side. Similarly, current I2 is flowing in this direction. So this should be a plus, this should be minus side. Okay, correct? Now, if you have any doubt here, because this will be important, if you have any doubt here, how you are assigning plus and minus sign to the resistances, please know. Okay, from simple, consider simple circuit. There is a voltage source, there is a resistance. Okay, current will flow from the positive pole of the battery to the negative pole. In that same way, in the same logic, we are writing this thing. And also, in other logic, like the energy is being absorbed by the resistance. That's why the voltage drop across the resistance will be in opposition to the voltage in the battery. Okay. Okay. Yeah. So how to write the equation then? In the, if you see, this is mesh 1. Now you are going in this clockwise direction. You are going in clockwise direction. So let us say you are starting with this battery. Okay, you are encountering the minus sign first. So it is minus 28 volt. Sorry, we are not writing volt here, minus 28. Then you are, if you move in clockwise direction, you are encountering the positive sign first. So it will be plus 4, but we need voltage. 4 is the resistance value. You need voltage. So Ohm's law, V equal to IR. That means how much current is flowing? 4 multiplied by I1. So resistance multiplied by the current that is flowing, the 4I1 will be the voltage drop across this 4 ohm resistance. Now, again, moving in clockwise direction, you are encountering this 2 ohm resistance. Now, in 2 ohm resistance, two things are happening. I1 is flowing from this side and I2 is flowing from this side. So this is I1, this is I2. Now, which will you consider? Whether you will consider I1 or whether you will consider I2. Okay, you don't know which is greater. If I1 is greater than I2, then definitely the net current through 2 ohm will be I1 minus I2 and in downward direction. But if I2 is greater than I1, then the net current that will be flowing through 2 ohm, that will be I2 minus I1, and it will be flowing from bottom to top. But we don't know the actual values of I1 and I2. That will come later. So while writing the equation, the KVL equation, that means we are writing the KVL equation for mesh 1. While writing the KVL equation or mesh 1, how you will write it? How will you assign the plus and minus? If the current is flowing from top to bottom, then this will be plus, this will be minus. Again, according to Ohm's law, V equal to IR, how it, again, if current is flowing in the this downward to top direction, then this will be plus, this will be minus. So now here some kind of ambiguity comes. So one rule that you have to remember is which is greater, I1 or I2, we don't know. But while writing the KVL equation for mesh 1, we'll consider that the current of the present mesh is greater than all other currents. That means current I1 is greater than I2, that means the net current will be flowing from top to bottom. That means I1 minus I2. Okay, that means there it will be plus, it will be minus. So first, moving in clockwise direction, will be encountering the positive sign first. So plus 2. 2 is the resistance, and net current that is flowing is I1 and I2. This should be equal to 0. That means we have written the KVL equation for mesh 1. Okay. Okay. 28 minus, that means you can take it on the other side. Okay. So okay, we'll solve like this, because they have taken here in this example, they have taken the this current in the opposite direction, not required. Whatever we'll follow, we will follow the same thing. That means here we are considering, if you consider this on opposite direction, it will be different. It will be plus. Okay, no issue. Now, both the currents we have considered in clockwise direction. So we are writing like this. So this can be further be simplified as 4I1 plus 2I1 minus 2I2, that is equal to 28. Or this can be further simplified here. That means 6I1 minus 2I2 is equal to 28. Is equal to 28. So this is the first equation we got this by applying KVL in mesh 1. Okay. Next in mesh 2, let me write it here. If you have any doubt, please let me know. We'll solve another example, many more example for this, so no issue. But still, if you have any doubt in how I am writing this equation, please let me know. Again, applying KVL at mesh 2. So how will you get? Okay, first let us start. We are moving in clockwise direction. Let us start. Okay, you are encountering this battery first. Moving in clockwise direction, you are encountering the plus sign first. So it will be plus 7. Okay, then you are moving here. Now, this is 2 ohm resistance. In 2 ohm resistance, now two currents are flowing. One current I1 is flowing in this direction. Another current I1 is flowing in this direction, I2. So what I have told, when you are writing the KVL equation for a particular mesh, then you have to consider that the current that is flowing in that mesh, that is the highest one. Here, let us consider I2 is the highest, has the highest value. Means I2 is greater than I1. Then you don't have to consider this I1. That means the net current that will flow will be I2 minus I1, and it will be in this direction, bottom to top. It will be in this direction, bottom to top. That means now again applying Ohm's law, this will be plus, this will be minus. Okay, so plus 7 volt, and again while moving in clockwise direction, you are encountering the plus sign first. So plus twice of I2 minus I1. What is the current flowing through this 2 ohm? I2 minus I1. Again, there is another current flowing here. There is current flowing through this 1 ohm resistance. But what is the current? Here, only I2 is flowing. Only I2 is flowing in this direction. So this will be plus, this will be minus. So you are encountering the plus sign first if you are moving. So plus 1 multiplied by I2, this should be equal to 0. Okay. So it will be minus 2I1. Okay. Minus 2I1 plus 3I2, that will be equal to minus 7. Okay. That will be equal to minus 7. Minus 2I1 minus 2I1 plus 3I2, that will be equal to minus 7. Okay. So this is equation 2. That means applying KVL in mesh 2. Now, can we add first equation with the second equation and we multiply, let us say 3. That means we are adding the plus equation and we are first we are multiplying the second equation with a scalar value 3, and you are adding this. Let us, so with equation 2, both sides of the equation will multiply it by 3, so it will be minus 6i1 plus 9i2 equal to minus 21. So let us say this is equation 3. Now we are adding equation 1 plus equation 3. Okay, so if you add 6i1 minus 6i2, that will be equal to 0. Minus 2i2 plus 9i2, that means plus 7i2. Minus, plus 28 minus 21. So it will be equal to 7. So I2 will be equal to 1 ampere and it is positive. So you have considered the correct current value. That means I2 is plus 1. That means I2 will be in this direction and its value will be 1 ampere. Okay. Similarly, if I2 is 1 ampere, then just if you put I2 here, so putting I2 in equation 2, then it will be minus of twice I1 plus 3 multiplied by 1. I2 is 1. So 3 equal to minus 7. So minus 2I1 minus 7. Okay, 1 minute. Yes. So then minus 7.
Sir,
Yes. Yeah.
sir, can you please repeat in brief the application of KVL in the second mesh?
Yes, I will. Definitely I will. 1 minute. 2I1 minus 10. So I1 will be 5 ampere. I1 will be 5 ampere and it will be in the same direction. That means this I1 direction 5 ampere. Yes, so second mesh. Okay, that means in mesh 2. Let us write it here. I'm removing this part and I'm again writing it. Forget about this thing. So we have started our discussion on this mesh analysis. This is what we are doing is mesh analysis. That means first we have to identify the number of meshes and what are the meshes. So this is a simple thing. This is a simple circuit. So we into the formula, we can clearly identify what are the meshes. Meshes are the loops without any loop inside it. Okay. So clearly we can identify these two mesh, okay, mesh 1 and mesh 2. So for these two mesh, we are assigning some unknown current, unknown variable I1 and I2. We don't know its value. At the end, as you have seen, at the end we will be able to find its value I1 and I2. And we also don't know what are the direction. Okay, so we are assigning the that the current I1 flowing in clockwise direction in mesh 1, current I2 is flowing in clockwise direction in mesh 2. Okay, that is the basic assumption we have considered. Assumptions can be wrong. Okay, assumptions can be wrong. So I think if mesh 1, how we are considering mesh 1 is clear, we are only focusing on mesh 2, let us say. Okay. Here, you are moving in clockwise direction, so you can start from any of the element. Let us start with this 1 ohm resistance. You are moving in clockwise direction. Okay, this. You are moving like this. That means if you are moving in clockwise direction, then you are encountering the plus sign first. So definitely you have to consider plus. Plus the voltage drop across this 1 ohm resistance. How you can find the voltage drop? Definitely V is equal to IR. We know what is the value of R, that is 1 ohm. 1 multiplied by I. I means current. Current, we have considered that, okay, through this loop, current I2 is flowing. Okay, that means through this 1 ohm resistance, only I2 is flowing. Okay, that's why 1 multiplied by I2. Is it clear? How we are
Yes,
getting?
sir.
Yeah. Then what is the next element in clockwise direction? Okay, this battery. Again, battery, this side is positive. That means if you move in clockwise direction, we are encountering the plus sign first. So plus. And what is the value of this voltage? 7. Then the next element is 2 ohm. Now 2 ohm is a common element between this mesh 1 and mesh 2. So through this 2 ohm resistance, you have to consider that both current are flowing. As you can see, I1 is flowing in this direction, I2 is flowing in this direction. Okay, so the net current will be flowing in this downward direction if I1 is greater than I2, and its value of the current will be I1 minus I2. The net current to this 2 ohm resistance will be flowing in bottom to top direction if I2 is greater than I1, and the magnitude in that case will be I2 minus I1. So which one to consider? So again, you have to use some kind of a convention. Definitely you can use the opposite one. But here we are considering that when we consider a particular mesh, we will consider that the current in that mesh is the greatest or the largest among the current with the that are flowing in the other mesh. That means when we are writing the KVL equation for mesh 2, we will consider that I2 is greater than the currents in all meshes. Here the other possible mesh is mesh 1. So I2 we will consider is greater than I1. That means this case I2 is greater than I1. So net current will be flowing in top direction. So I2 minus I1. Okay. So this thing we will not consider. This we have already considered for mesh 1. So in that case, if the current is flowing in this direction, so what will be the plus and minus sign? Again, KVL, sorry, Ohm's law. That means here you are giving this battery and you have across this resistance R. So this is plus, this is minus. So again, current will be flowing in this direction. Let us say current is flowing in this direction. Definitely this should be positive, this should be negative. Here, this side should be at greater potential than this side. Then only the current will be flowing in this direction. So here also, if current is flowing in this direction, definitely this should be plus, this should be minus. So if you are moving in clockwise direction, you are encountering the plus sign first. So plus sign. Again, what is the voltage drop? V is equal to IR. So what is the resistance? That is already given 2 ohm multiplied by what is the net current? We have considered that net I2 is greater than I1. So net current will be I2 minus I1. So net current is I2 minus I1. And the sum should be equal to 0 according to KVL. Okay. So now I2, here it is I2, here it is I2. 2I2 plus 1I2. That means 2I2 plus 1I2, 3I2. Okay. These two you can multiply here also. So minus 2I1 minus 2I1, that is equal to minus 7. Is it clear? Is it clear?
Yes, sir.
Yeah. So now you can just solve two equation, two unknowns. You can solve it. Okay. In whatever way you do solution of simultaneous equations, you can do. Okay, that you have already done. I have also solved it here. Now we'll solve this multiple times. We'll see now more specific example. Like someone was asking like, what happens if there is a dependent source? All those one by one. Okay, so this one is okay. Now see, in their case, I1 we have found plus 5 ampere. Okay, they have also found, okay, I1 is 5 ampere because I1 they have also considered in clockwise direction. But I2 they are finding it as 1 ampere. The same, the magnitude is correct, but for us it was plus 1 ampere. For them it is minus 1 ampere, because they have considered I2 to be flowing in, see, counterclockwise, anti-clockwise direction. Now their assumption then it is wrong. They have considered I2 to be flowing in counterclockwise direction or anti-clockwise direction, and they are getting the minus sign. So definitely then the direction will be in opposite direction, that is in clockwise direction. So our assumption was correct. Assumptions can be wrong, no issue, but the final answer should be correct. Now we will consider this mesh analysis for different cases. Let us say we are considering a first case, this case 1, when the current source exists in one mesh only. There is a current source. There is a current source. Now how you can deal with this kind of a problem? Okay, let us see. The solution you will get, I will solve it by hand so that each and every steps become clear to you. When I will share the lecture notes, the solutions will be there, no issue. But here I will solve by hand. So let us first draw the circuit. Okay. So there is a, again, what kind of source it is? It is a independent source. Circle is denoted by a circular diagram. That means it is an independent source, and inside it there is plus and minus. So definitely it is a independent voltage source. What is the voltage? 10 volt. Okay. Next, there is a resistance of 4 ohm. There is another resistance of 3 ohm. There is a current source of 1 ampere. Again, independent current source. That means a circle, inside it there is an arrow. So 5 ampere, and beside it 5 ampere is shown. So 5 is the magnitude of the current, and the direction will be in the direction of the arrow that is inside the circular region. Okay. There is another resistance of value 6 ohm. Okay, and it is coming like this. Now what you have to do? You have to find out the currents in the both the mesh. Okay, first you have to identify the mesh. So this is a node. Okay, this is a node. This is a node. This is a node. So 4 nodes. How many number of branches? Between each and every node, if there is a path, that will be the branch. So this is branch 1. This is branch 2. This is branch 3. Branch 4. Branch 5. So 5 branches minus 4 nodes plus 1. So again 2 mesh. You can directly, by seeing the circuit also, you can say that there are 2 mesh. Let us say this is mesh 1, this is mesh 2. So what is the first step? You have to assign some unknown currents to each and every mesh. So let us say some current I1 is flowing through here. Some current I2 is flowing through here. Again, the direction of the current I1 and I2 that you are considering, it can be anything, either in clockwise direction or anti-clockwise direction. That doesn't matter. As you have seen, if you make the wrong assumption, your answer will give you the correct one. Okay, but before solving, you have to clearly mention what are the assumptions. That means I1 and I2, let us say that they are the currents, and you have to clearly show whether those currents are flowing in clockwise or anti-clockwise direction. Okay, so that is important. We will consider mesh 1. We will consider mesh 1. Okay, that means applying KVL at mesh 1, in mesh 1. What you are getting, okay. Before that, we have to assign the plus and minus sign. For the battery, it is already the plus and minus sign is given. But what about this 4 ohm? In the 4 ohm current, I1 is flowing. I1 is flowing in this direction, I1 is flowing. So definitely this side will be at higher potential, this side will be at lower potential. Now, again, the resistance in this mesh 1 is 6 ohm. Now in 6 ohm, 2 currents flowing, I1 and I2. 2 currents are flowing. So we don't know in which direction the net current is flowing. So we won't be able to write this plus and minus. But what is the assumptions that we have considered? That if you are considering a particular mesh, the current in that particular mesh will be the highest one. That means here, when you are writing the KVL equation for mesh 1, I1 will be the highest current. That means I1 is greater than I2. If I1 is greater than I2, then what is the net current that is flowing through the 6 ohm? I1 is flowing in this direction. I in this direction. We are considering I1 and greater than I2. So the net current that will be flowing in the 6 ohm distance will be in this direction. Of I1, I2. So and what will be its magnitude? I1 minus. Now, if this is the case, if the current is flowing in this direction from the top to bottom, then definitely this will be positive side, this will be negative side. Now you are ready to write the KVL equation at mesh 1. You go in clockwise direction. Let us say we are starting with this 10 volt, this independent current source. If you go in clockwise direction, what is the sign that you are encountering first? Minus sign. You are moving in this direction. That means you are encountering the minus sign first. So minus of what is the voltage? 10 volt. Then if you move in clockwise, if you continue moving in clockwise direction, that you will encounter is 4 ohm. Okay, in 4 ohm also you are encountering, if you are moving in clockwise direction, you are encountering the plus sign first. So plus of 4 multiplied by what is the current that is flowing through the 4 ohm resistance, that is I1. Then the next element is 6 ohm. Now in 6 ohm, if you move in clockwise direction, you are encountering the plus sign first. So plus 6. Sorry, plus 6. And what is the net current flowing? That is I1 minus I2. So 6 I1 minus I2. That should be equal to 0. So 4 I1 plus 6 I2 I1. So 10 I1 minus 6 I2. This one. 6 I2. So 10 I1 minus 6 I2, that will be equal to minus 10 volt. You can bring it on the right hand side, so it will be 10 volt. So this is the first equation. Is it clear how to apply the KVL in a particular base? Let me know. Let me know in the chat. Now the circuit is given to you. Can you just write the KVL equation in the chat? Can you write the KVL equation of mesh 2 in the chat? Can you write KVL equation in mesh 2? Yes, sir. Please write down. In the chat, you can write I1. After I, you can write I1. You can, and again I2. Then you can write 2. In that way, plus minus all the things you can do in the chat. Please try to answer that. How to write the KVL equation in mesh 2? Please, I'm waiting for your answer. In the meantime, I will take the attendance, and by that time, try to write in the chat like what will be the KVL when you apply it to mesh 2. Okay. Leave. I am taking the attendance. If you leave, you won't get the attendance. Mayank Sharma is present. So today is 21/8. The present. Mayank Sharma. Abhijit Biswas is present. Abhijit Biswas. Akash Rai. Akash Rai is present. Anand Krishna Singh. Anand Krishna Singh is present. Areen Agarwal. Devanshu. Nil. Pratik Raj. Rajveer Rawat. Shashi Sekhar. Shreya Yadav. Okay, if I have not called out your name, please say. Okay, please write down. Okay, you have. Okay, Asutosh Yadav. Asutosh Yadav is not there. Okay, if I have not called your name, please let me know. No one is writing. I don't know why. Is it not clear how to write the equation? Is it not clear? What is the problem that you are facing? Don't leave. The class is not yet over. I have taken only the attendance. Please write down. Try to write down this. These are the basic theorems that we'll be using. Things will become more complex. So if these basic things are not clear, you won't be able to understand the complex problems. Okay. So write down. Try to write down what is the KVL equation at mesh 2. KVL at mesh. So you can understand. So now we have to go to the basics of again what I have told for a current source. If you have heard it carefully, that for a again this is a dependent current. Sorry, this is an independent current source. Circle, inside the circle there is an arrow, and beside it magnitude of the current is given. So magnitude is 5 and the direction is also given. So it's an independent current source. Now for independent current source, what is the main aim of independent current source? It maintains the same amount of current in that particular, in all the elements that are connected in series. So if you see that I2 will always be equal to 5 ampere. The it will be 5 ampere because see here I2 is flowing through this part. I2 is flowing through this part. So I2 will be same as this 5 ampere current source value, but the only thing that will be different is the direction. The direction that we have considered is in opposite with the given current source. So I2 will be equal to minus of 5 ampere. You don't have to write any other equation because I2 was the unknown. To find I2, you are writing all this KVL. But here, from the basic understanding of a current source, you can say that, okay, I2 is nothing but equal to 5 ampere, but the sign is different. So I2 will be equal to minus of 5 ampere. So the first equation was this 4I1 plus 6I1 minus I2 equal to 10. And I2 you have already got as minus 5 ampere. Just put the minus 5 ampere here and you will be able to get like this. Okay, we'll be able to get this. I1 will be equal to minus of 2. Just you have to put I2 is equal to 5 ampere in this equation, KVL equation for mesh 1. You will get what is the value of I1. So I2 will be in this direction. So both the direction we have that we have considered are wrong. Whatever we have assumed that were wrong. So I2 will be flowing in this direction, that is of 5 ampere value. I1 will be also be flowing in the opposite direction, that will be of value 2 ampere. Okay. Now, this is the last problem that we have done. There are many other cases. One by one we will consider, and there is a very important called super mesh. Now you will get questions out from this super mesh concept. Again, when we will do nodal analysis, super node concept is there. Very important concept, and you will get questions from this. Okay. So till now, if you have any doubt in any of the like problems that we have discussed, please let me know. Otherwise, we'll stop today here. Tomorrow we'll again at 10, I think your class is at 9. So tomorrow we'll again start from here. Okay. Mesh analysis. Okay, Anak, you can leave. Those who have no doubt, they can leave. And those who have doubt, please let me know. There are 3 more minutes. Okay. Then I have to stop the session because there will be another class. Okay. Yes. So if you have no doubt, you can leave. Again, please like start tomorrow at 9 a.m. Okay.
Recording